This is problem 4, section 4.3, problem number 42. We're going to graph the function by finding the vertex, axis of symmetry, whether or not the graph opens up or down, the y-intercept and x-intercepts, if any. The second part is going to be to find the domain and range, and then where the function is increasing and where it is decreasing. The function we are going to solve is f of x equals negative 3x squared plus 3x minus 2. There are two ways to find the vertex. One, we could complete the square, and the other, we could use the opposite of b over 2a, and we're going to do both. So we could complete the square. So that we get the form f of x equals a times x minus h, the quantity squared, plus k. Or we could also find opposite of b over 2a and then put that back into the function to find the y-coordinate of the vertex. And we're going to do both of these. You would not need to do both of these, but just for the educational purposes, we're going to do both. So we start with our function f of x equal negative 3x squared plus 3x minus 2. And we factor out our a, which in this case is going to be the negative 3, just out of our first two terms, x squared minus x, and then we're going to shift that minus 2 over. And now what we're going to put here is half of what we have here, and again, that's an implied 1, but we have negative 1, and so half of that is negative 1/2, and we will square that so we get plus 1/4. And now we need to subtract that off to keep everything balanced, but that isn't just adding 1/4, it is adding negative 3 times 1/4, which is negative 3/4, so we're going to have to add here a positive 3/4. All right, so then we end up with negative 3, that's our a, x minus 1/2 squared minus 1 1/4, which is 5/4. This is negative 2 is 8/4 minus 8/4 plus 3/4 gives us a negative 5/4. So based on that, our vertex HK should be at 1/2 and then negative 5/4. Now I said we were going to do it two ways, and so we're also going to find the opposite of b over 2a. That should be what h is, and that gives me, I have a positive 3 here, so negative 3, the opposite of that, multiplied by 2 times negative 3. Well, our negative 3's cancel, and we end up with h equals 1/2. K and then would be, in fact, f of 1/2. So we end up with negative 3 multiplied by the quantity 1/2 squared plus 3 multiplied by 1/2 minus 2. This gives me negative 3 times 1/4 would be negative 3/4 plus 3/2 minus 2. Finding common denominators, we have negative 3/4 plus 6/4 minus 8/4. Negative 3 plus 6 is positive 6, negative 8. This gives me negative 5/4. So two separate ways we found our vertex to be at the point, vertex is at the point 1/2 negative 5/4. So there's our vertex. Finding our axis of symmetry is now easy because we know that it goes through the vertex. So we know that the axis of symmetry is at the point or at the line x equal 1/2, because the x, it goes through the vertex, so it's equal to h essentially. We know a is -3. We completed the square and found our equation here. And we have here that the -3, that's a. We know that means that because it's negative, that this parabola opens down. And so we have found our first three things. The next thing we have to find are our intercepts. So we are going to look for those. Again, so far we have found our vertex is at 1/2, -5/4. Our axis of symmetry is at x equal 1/2. And we know that this is our function again, and we also know that f of x equals -3x minus 1/2 squared minus 5/4. And now we're going to find our y-intercept. And we know that when we find our y-intercept, that x equals 0. And so all we have to find is f of 0, which becomes, we know that it's, then our intercept is -2. So now we have another point, 0, -2, and then we have to find our x-intercepts. That's the last piece, x-intercepts. And so we have f of x equals -3x squared plus 3x minus 2. And we can look at that trying to factor this. The AC method tells us that we take the a, which is -3, multiply it by the c, which is -2, and we get 6. And b is 3. So we're trying to find something that multiplies to be 6 and adds to be 3. And we don't have anything readily apparent. We know that 1 times 6 is 6 and 2 times 3 is 6, and that's really all of our options, and neither of those add to 3. So we're going to have to resort to using our quadratic equation, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And that would give us a -3 plus or minus the square root of 3 squared minus 4 times -3 times -2, and all of that over 2 times -3. Okay, so then this would equal -3 plus or minus the square root of 9 minus, this is -4 times -3 is positive 12 times -2 would give us a -24. 9 plus a -24 gives me the square root of -15, and all of that is over -6. But taking a little step back, we have a negative under the square root here. We know that not to be real, and so we also had learned about the discriminant. And so because b squared minus 4ac is less than 0, we know we have no real intercepts or solution to this problem. So we know we have no intercepts, so that means we have no x-intercepts. The conclusion to that is no x-intercepts. But if we just take 1 minute to think about this, it makes sense to us because our vertex is at 1/2 negative, I'm just going to draw a tiny picture, 1/2 negative 5/4. So we're down here somewhere, and we know also that this opens down because our A was was negative. So if we have something like this, we know that we're not going to have any x-intercepts. So that makes sense to us. Okay, well, we have everything now, and we can go ahead and graph this. So, of course, it all goes off my page. So I'm going to write the vertex here again. Our vertex is at 1/2 negative 5/4. We know we have that it opens down. We know that we have an axis of symmetry at x equals 1/2. We know that we have a y-intercept at the point 0, -2. And we have no x-intercepts. And so here we go. Let's just go ahead and graph this. So we have our y-axis and our x-axis. There's 1, -1, and so on. All right, 5/4 is just a little bit over 1. It's 1 1/4. We know we're at x equals 1/2, and then this would be 1/4. So here is our vertex, and it opens down. We also know that our y-intercept here is at 0, -2, and we know because our axis of symmetry is here at x equal 1/2 that whatever happens on this side has to happen on this side. So we know we have another point here. This is 1, -2. This is 0, -2. And this, our vertex, is at 1/2 -5/4. And all we have to do is connect these, label our axis x and y, and we have our function graphed. Okay, so we are done with part A, which is graphing, and now we want to look at the domain and the range and where it's increasing and where it's decreasing. So our domain, the values that x could be, is from -infinity to +infinity. We remember to put a parenthesis or curve because it doesn't include those points. Our range goes from -infinity the y values could be anything down -infinity all the way up to the highest point, which is -5/4, and it does in fact include that point. So we will make that a square to indicate that it's included. Where is this increasing? Well, as x gets bigger, the y gets bigger on the range from -infinity for x values, from -infinity all the way until we get to 1/2, and it's decreasing from 1/2 as we get larger and larger x's to infinity. So those, the increasing and decreasing, those are our x values that are increasing and our x values that are decreasing. And that's it. There's the answer to our problem.